Here's a solution to quiz 4. This is just one of the two versions of the quiz, but the details are not that different. The first we're doing an improper integral, so we're doing it in two steps. First we're doing the fundamental theorem of calculus with a parameter. Oops, need black. We're integrating from 2 to n, x to the minus 5. And that'll be the power rule. And so the way I do the power rule is I first figure out the power that I want. So I need the power that's one more than x to the minus 5. And then the number that multiplies in front is just the reciprocal of that new power. So I end up with something where I have the new power and the reciprocal of that power as a number in front. We integrate from 2 to n, and so that's negative 1/4 n to the minus 4 minus negative 1/4 times 2 to the minus 4. This is worth, because we're going to have to do a limit in a second, it's worth rewriting this so that there are fractions involved. So the first term is that, and of course we have minus minus there, and a fourth times 1 over 2 to the fourth is 1 over 64. So that's what goes here. Made that look worse and worse. Hang on. So I have minus 1 over 4 n to the fourth plus 1 over 64. So this term has the denominator growing to infinity while the numerator, it doesn't change. So the numerator is constant. So that's the base case for our limits at infinity, really. We have a constant numerator, the denominator going to 0 means that this fraction is going to 0. And so this expression gets closer and closer to 0 plus 1 over 64, which is just 1 over 64. So don't forget that this is actually the interpretation of an area problem. We have 1, 2, blah, 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 blah. So 2 is there. We have the curve y equals 1 over x to the fifth. And the integral from 2 to infinity means we're starting at 2 and shading in everything forever out to the right. So the region is unbounded, goes on forever out to the right, but the area of the blue shaded stuff is 1 over 64. So that's what that means. I'm pointing that out because some people said the answer to the integral was 0 because they were thinking about part of it going to 0, but not the whole thing. But obviously, if it's the area of a positive curve, area under a positive curve, there's no way that the answer could be 0. All right. L'Hopital's rule using the chain rule. So we need to know the derivative of the numerator and denominator here. So the numerator's derivative is 1 over 1 plus x. Technically, that's the chain rule because we're also multiplying by the derivative of 1 plus x, but the derivative of 1 plus x is just 1. So that is the derivative of the log of 1 plus x, but then the derivative of log of 1 plus x squared. Same thing happens, but now the derivative of, oops. The derivative of 1 plus x squared is not just 1, it's 2x. So I'll have 2x over 1 plus x squared. So that's the derivative of my numerator and denominator. So L'Hopital's rule, if I label this, L'Hopital's rule says that this limit should be the same as the limit of the ratio of the derivatives. So let me resolve those fractions because that's hard to think about. I'll have the top fraction times the reciprocal of the bottom fraction. And so that is the limit as n goes to infinity of 1 plus n squared over 2n plus 2n squared. So that's the same problem. That limit should be the same as the original limit, but now this is just a rational expression over rational expression. So we can either notice that this is still the infinity over infinity indeterminate form and use L'Hopital's rule again, or we could use our knowledge from that goes back to pre-calc, where we know that these two terms are the highest degree terms, and so the ratio of those two terms really is going to be the answer in the end. So this is going to be 1/2. If you're not sure about that rule about the highest degree terms, then by all means just do L'Hopital's rule again, but you should end up at the limit being 1/2 in the end.